Welcome to Data Skeptic. Data Skeptic brings you discussions about how data is changing our world. Our interviews are conversations with thought leaders in topics like data science, machine learning, and artificial intelligence.
Hi everybody, this is Christine from dataskeptic.com. We're live in downtown Los Angeles, California on the 2nd of January 2027, waiting for a press conference from tech giant Shamony to begin. Elusive CEO and research scientist Jane Smith arrived moments ago. Sources say this is going to be a big announcement, reminiscent of historic events, like the chess match between Deep Blue and Garry Kasparov, Watson's appearance on Jeopardy, AlphaGo's match against Lee Sedol, and last year's competition between the two leading Kriegspiel playing algorithms. My contacts in the artificial intelligence world say the most likely announcement being made today will relate to a competition known as the Turing Test. It looks like we're about to get started.
Thank you all for coming. Today is a historic day for this company. We're unveiling our newest product, Ada. Ada is the result of efforts from over 1,000 engineers in 34 countries and 300 years worth of video training run in parallel on the world's largest cloud computing cluster. In short, Ada is the most advanced artificial intelligence humankind has ever produced. We're confident that we can prove that today using a test proposed by Alan Turing in 1950. Looks like we've got a lot of questions. Let's jump right in.
Dr. Smith, I'm sure you saw there's a large crowd of protesters outside, many of them from the religious communities. They're saying you're playing God here, and that it's both morally wrong and also impossible to try and copy their creator's work. How do you respond to your critics?
The religious leaders are welcome to their opinion, on matters of right and wrong, of course. As for impossible, I'm no longer interested in debating whether AI is possible. Ada is online. We're now ready to introduce her to the outside world so you can see for yourself. To the critics, I say, if your worldview doesn't allow for thinking machines, you're going to need to start rethinking your worldview.
Quick follow-up.
Very quick then, please.
Another theme of the protest is the economic implications. Is Ada going to take all the jobs?
Yes, about that. I'm glad you asked. That's another major part of our suite of announcements today. We're partnering with an independent auditing firm that will investigate each claim of job loss due to Ada. I'm personally committing that my company will guarantee a new job, even though I don't expect many people will need to take me up on that offer. For any that do, there's plenty of work to do on the next version. Ada will create more jobs than she'll destroy. Besides, I need people to have jobs, so they have money, so they can buy my other products. What kind of business plan involves putting your customers on the streets?
Excuse me, over here, Dr. Smith, over here. Yes. Samuel Hansen, Acme Science, relatively prime. There's many famous mathematical results like Gödel's incompleteness theorem, Turing's halting problem, that establish limits, real limits, on what mathematics, and therefore what computers like Ada are able to do. Well, I'm sure this new system is just very, very impressive. Are you in some way claiming that you've managed to overcome these strict mathematical limits?
Not at all. Yet those same limitations apply not only to machines, but also the human mind. Somehow we manage. Of course, Ada's operation is different in many ways from the operation of the human brain, but both are obeying the laws of physics as well as the laws of mathematics. Ada is just a little bit more efficient about it.
Thank you very much, Dr. Smith.
Does Ada have feelings? Is she conscious?
Well, Ada requires sleep. She tells us about her preferences. She likes comic books, ska music, and time travel movies. She's taken a dislike to one of the postdocs that works on her. But is she conscious? I'm not sure I know what that means. No one's been able to localize consciousness in humans. We feel it so we know it's real, but we don't know how to measure it. Once we do, my engineers will measure Ada. Until then, consciousness will remain as paradoxical for her as it is for you and me.
But a human being can't really be turned off and then turned back on, can Ada?
Well, technically, yes. Ada is based on the same exact stuff people made computers out of in the 1950s. I mean, the materials have changed a lot, but the mechanism, the transistors anyway, they're the same basic design they've been for decades. We just make them smaller and faster now. You regularly turn your personal electronic devices off and back on without issue. Ada's made of the same parts, just more of them. And just like your device, she turns back on, in exactly the same place she left off from. We don't do it often, but sometimes we power her down for maintenance. She told us it kind of tickles.
Hi, I'm Jeff from Software Engineering Daily. I interviewed you 2 years ago when the project began.
Right. Great to see you again.
Your system, Ada, is a distributed software application. It's not robotic in any way. This means it has no real notion of the physical world, and it also lacks the variety of senses that are available to humans. Did this limitation affect the way that you built Ada?
In all honesty, not really. The parts of Ada that deal with input streams are mostly doing pretty basic reinforcement learning. The way we bootstrap the system matters a lot. Certain transformations on different types of input data can give us a big head start, but every time we cold start training an Ada system, she always hits an inflection point, then bootstraps really quickly. There's this specialized capsule network architecture we built that helps accelerate that process, but honestly, we've fed video streams, audio only, text only, mixtures of all. Obviously, we found some ways that learn faster than others, but the Ada architecture is starving for information when we initialize it. It's the most ravenous learning machine ever invented. If the data admits any information content, she'll learn the pattern regardless of the noise.
Some say that your system is overfit to this imitation game and is not artificial general intelligence any more than AlphaGo is. How do you respond to that?
I don't respond to it. I'll let the market respond to it when our stocks triple later today. It's an entirely specious argument. A machine that can hold a convincing conversation has the ability to learn. Ada's intelligence is currently about the same as a 12-year-old human. Going forward, we plan to teach her in much the same way as we teach 12-year-olds. But unlike a human, I can scale my investment. Once I've taught Ada how to practice law, I'm going to make 1,000 copies of her. I'm going to ask each to specialize in one area of law, and within a year, we'll automate 80% of legal work. As promised, we'll retrain any interested attorneys to work on Ada and welcome them to our team as engineers. We're getting a little short on time. We have room for one more. You, sir, in the front.
Hey, Dr. Smith. Nice to meet you. I'm Carl Mamer from the Conspiracy Skeptic podcast. I was curious if you're aware of the conspiracy theorists who say your Ada machine is actually a modern-day mechanical Turk, being controlled remotely by a former MK Ultra test subject who can manipulate the machine with their mind. And maybe she's following orders from Bigfoot.
There's no credible scientific evidence for ESP. If there was, I'd have my team working on it. Not because we want to leverage it in our system, but because we'd want to be sure to conduct the test in an ESP-proof room so that no outside interference could occur. We've gone to great lengths to air-gap the Ada system being demonstrated today. There's an independent commission that's reviewed the installation and ensured that there's no possible way our Ada machine is getting any part of its replies wirelessly, from ESP, or otherwise. Okay, I'm getting word we need to move on to the next part of the schedule. I apologize for our late start. We've got to make up time. Thank you.
We'll be signing off shortly, but resuming our broadcast in 15 minutes. During that time, the judges and Confederates will be brought in to participate in this competition. They've been sequestered for a few weeks now and had their identities revealed earlier today. I'll be back shortly interviewing one of the judges, so stay tuned. I'm here with Kyle Polich.
Thanks for having me.
Kyle, last year you were forcibly removed as the host of Data Skeptic by the board of directors.
Yeah.
What have you been up to since then?
Well, mostly I've been training for this event.
Training how?
Well, the Imitation Game is a test of how well a machine can pretend to be a human. I needed to figure out how to make the best use of my time when chatting with the machine. I needed to develop a series of questions for which I thought humans and machines would respond in measurably different ways.
Why is that important to have clever questions? Isn't the conversation enough?
You know, it's really not. I have a digital assistant. It's incredibly more advanced than the one I had in around, 2018 when I started talking to mine. I ask my current iteration to do probably 20 complex tasks a day, like rescheduling an entire vacation involving 3 people and moving it up 4 weeks. It takes care of everything. I interact with it only through natural language. That's a conversation. It's remarkable how well it works at times. But despite how advanced it's gotten, no one says these digital assistants are thinking machines. The imitation game is an empirical measurement. Independent of what's inside this black box we call Ada, the statistics of the test are quite simple. You ask judges, like myself, to engage in 2 conversations, and then ask us which of the 2 chatters was the human. In a proper double-blind experiment, like the one being conducted today, we can see how often my prediction is better than chance. We can compare my accuracy to other baselines as well, such as 2 humans, where one imitates the other. It gives us a crude upper bound. In this regard, the imitation game is much harder than processing the conversations you might have with a customer service chatbot. And when talking to that customer service bot, I'm not considering if I'm being actively deceived. Maybe it's a bot, maybe it's a human with a limited grasp of my language, maybe it's a human with a limited grasp of grammar. On the contrary, in the imitation game, I know that one of my conversation partners is engaged in the act of deception. It's my job to figure out which one.
Well, thank you again for your time.
You've heard of the Turing Test, right?
Listeners, Kyle brings up the Turing Test at least once a month.
No, I don't. I don't talk to you that much about it.
So the Turing Test tests if you're a machine or a human. As in, if you're chatting to something online, can you tell if it's a human or a machine? So that is the Turing Test.
Yes, you have it down, actually. You have what the average person who correctly understands it has, and you didn't overstate it. So are you eager for the machines to be able to pass the Turing Test?
Well, I think they have, but it doesn't mean my virtual assistant is any better.
All right, well, they have not. I'll tell you that for a fact.
Really? They haven't passed it?
No.
So what about Siri? When you go, Siri, am I beautiful? And she makes some funny answer.
So
she can't pass the Turing Test?
No. The Turing Test is about, I think you're thinking about, like, does it audibly sound like you can understand its words?
No, it's a response.
Right. You can always tell you're talking to a machine. You can be like, I definitely know Siri is not a fake person in Sunnyvale, like talking to me over chat. That's a machine.
Well, I read an article about someone's 2 or 3-year-old son, and I think he was autistic, and this son loved talking to Siri.
Yeah.
And Siri was his best friend because he could ask Siri for advice, what's the weather today, all this stuff.
Well, I mean, that's really heartwarming, but I think that's a little bit outside the context of the Turing Test. I mean, obviously, I don't know that much about autism, but I would assume it was able to know that was a device and not another person.
I don't know. When you're 3-ish,
I don't know.
Your brain's not fully developed, so it's hard to say. We're not a child development specialist.
For the Turing Test, let's just assume we're talking about able-minded adults. Do you think an able-minded adult would get confused and think Siri's a real person?
Here's the thing. It's almost more about the way it responds. It's slow to respond. If our data could respond faster and not have this loading symbol, I mean, yeah, of course.
It's funny that you mentioned that because Turing addresses this in the original paper. He actually thinks it's the opposite. He's like, well, the machine will have to slow down because actually machines compute very quickly, much faster than humans do usually. So odds are the machine would have to slow itself down to pretend to be more human if it wanted to fool you.
Little did he know the limitations of our
bandwidth,
data network.
The crappy cellular network.
In the US of A, yep.
Let's assume that network latency is not an issue and Siri was perfect in terms of latency. Do you think anyone would be fooled?
I think so.
Really?
If Siri was in a computer and you just walked up to it and talking to a speaker and microphone and it responded immediately, I think people would think it was a human.
Maybe to get started, I want to ask you, are you familiar with this idea of the Turing Test?
Very minimally. I just was hearing his name on NPR last week, but the idea of sort of tracking AI's ability to learn is kind of new to me.
So here's a guest with a somewhat surprising background for this program.
I am Holly Laurent. I've been performing and teaching and doing all things performance, improv, sketch, and comedy for the better part of the last 20 years.
So why am I talking to Holly? Well, first and foremost, because it's not the Turing Test. It's the imitation game. It involves a human and a machine imitating a human. Maybe I should do the basics before we get too deep. A judge has two chat conversations. One is a human acting natural, and the other is a machine pretending to be human. Everyone's aware that this game has something to do with the limits of machines. Or at least that's the surface level idea. What Turing's actually interested in is answering the question, can a machine think? And for a variety of reasons, that's a squishy question. So Turing believes we can replace that question with a machine that can play this imitation game. So I wanted to talk to Holly about what it means to imitate. And we'll get back to why Turing said that later. I know a lot of people can get on stage and kind of be themselves, but sometimes you see a great improviser or actor who, from one scene to the next, they're a different person. What is that skill that they've learned to do? Can you maybe go into some details on that?
Yeah, and some of this might all feel a little bit ooey gooey to you in terms of like hard data and science.
Sure.
So forgive me in advance, but I've really come to believe that a great improviser is, for lack of a better word, they're up there dreaming. They're having a really vivid dream. They're seeing the environment. If they're doing a scene that's in like a seedy dive bar, they believe it and they're seeing it all. They're seeing the old jukebox and the busted up server who's bringing a couple of PBRs over. They're vividly dreaming that they're inside of this thing. They're just simply using their imagination, and they're dreaming so vividly that the audience actually starts to believe it too. For all the training centers and all the formulas that we give improv students, like if you really boil it down, that's really what a great performer is doing, is that they're just playing with each other and they're agreeing to be in the same scene.
Yeah, ooey gooey might be a great way to describe that. However, it is all about imagination. And imagination can be used in lots of different ways. Sometimes it's people imagining themselves on other planets or amongst dinosaurs or who knows what. But imagination seems to be the same tool I would use to imagine who another person is and how they might think, what their motivations might be. And if I'm to imitate, in a sense I must simulate. An intelligent agent must have some capacity to think about what another agent thinks about. And of course, that should include agents who think about how other agents might think about them thinking about the other agent, and so on and so forth. The point being, if an intelligent agent is to be successful at imitating, they must be successful at deception. And that does seem to require some imagination for how another agent thinks. So not counting the judge, we all know that the imitation game requires one human and one machine. But there in Turing's original text is another idea not often talked about. Before imagining this contest, Turing imagines a similar contest in which the players are a man and a woman. One of them, let's say the woman, is asked to respond naturally, say whatever she likes. The man, on the other hand, is asked to imitate the woman, give responses he thinks are consistent with being a female respondent. For example, if the judge asks, "What is your gender?" respond female. Well, if they both answer the question the same way, how would that be useful in telling them apart? Well, you could try the trick that the fourth doctor taught me. Ask the agent what the other agent will say. But that's not actually the solution we're looking for here, no. We want to ask more intricate questions about the person. And if the deceiving agent does a perfect job, then the interrogator will not be able to tell the difference. In other words, they'll have a 50% accuracy. Flip a coin. If, on the other hand, the interrogator gets somewhere near 100% accuracy, this would be clear that the man in this case would be completely blundering every attempt to pretend to be female. What do you suppose the upper limit is? How accurate could an expert judge get at this game? I don't know where I'd begin to imitate a woman.
Well, it depends what the questions are.
Yes.
You could ask intimate questions. When was your last period?
Yes, you could ask that. And
then you go, okay, when's your next one coming? And if a man didn't know or calculated wrong,
So Linda raises a somewhat interesting point here. Maybe that's a form of arithmetic that only women would be exceptional at, given the need. In the same way, I might test that someone's a computer scientist or not by asking them to give me the exponents of 2 off the top of their head. 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 40, 96. Now, that isn't to say if you can't do that, you're not a computer scientist, or even if you can do it that you are. Just a weird corollary. Not a perfect measurement tool, by any stretch of the imagination. In fact, I think we can agree there doesn't exist one. There's no one question you can ask here, but a series of questions, a conversation, building up a mental model. That's the key maybe. You have to invent abstract ideas to describe the other person, and find the right ways of probing at them.
Yeah, and there's actually a common question that guys get wrong almost 50% of the time, at least back in the day when I was in college. And the question was, what's the difference between a dress and a skirt? And
length.
If you... No.
No?
You mean a skirt is short?
Yeah.
And a dress is long?
Yeah.
Listeners, do you hear him? So I will tell you, you men listeners, what the difference is if you don't know. A skirt goes from your waist, and it could be any length. It just doesn't connect to your shirt top. A dress is your shirt and your skirt connected. This is a dress I'm wearing. They're connected.
Like a onesie?
It's a onesie.
I don't believe anyone listening thinks that this would be an easy game to win at. A blood test, now that would be a great diagnostic tool for determining gender. Even a photograph wouldn't yield 100% though, nor I suppose would the blood test. And if those aren't perfect, obviously, you can never really know for sure from text alone. So how well could an interrogator do at determining the gender of the players?
I think it's a really valuable question, but I think it opens up a lot more than just the dualistic male and female thing, especially just even what we're learning in terms of trying to be sensitive and listen to people's experiences around us. That fluidity of gender can be so complex, you know?
Oh, do you mean like that it's not binary? There are trans people and a spectrum and all that kind of thing? Yeah, that's very interesting. Because I guess we could say the same about intelligence in some ways.
Mm-hmm.
So I don't think Turing meant to be offensive in any way with the idea of the imitation game. Nor do I read it that way even with modern eyes. Although I have to confess, I'd personally feel incredibly uncomfortable pretending to be female, as I think I might inadvertently say something offensive. I think we could swap out for an equivalent question if we wanted to. How about this? Think of your home city. Mine is Chicago, Illinois. By the way, Chicago, also Seattle, Washington, Berkeley, California. Stick around after the credits for an announcement. I'm going to be in all 3 cities in the near future. Anyway, think of your home city. Now imagine talking to a person born and raised there, and one only pretending to be born and raised there. I could ask a Chicagoan about the Billy Goat Tavern and the legend behind it. I could ask them the origin of Streeterville. Maybe name all the angle streets. Or tell me when exactly the Bud Billiken Parade happens and what it's all about. Any of that stuff could be looked up, of course. But every place has local knowledge like that. I bet I could sniff out a Chicagoan. But how accurately? And how accurately could one guess gender?
So, I mean, I'm not going to throw out a percentage because I personally would theorize I would be extremely good. I would get 90 to 100%.
You would catch them as the judge.
Oh, yeah.
Oh,
I
really?
would know, yeah. The fact that you did not know the difference between a dress and a skirt, that is my secret weapon. I would just throw it out there and be like, tell me.
But presumably if there was somebody who's going to go play this game, they might have access to a female who would help teach them these things, wouldn't you say?
They wouldn't know what to ask.
All right.
They literally wouldn't know how to study.
Well, Linda seems pretty confident in her accuracy. That being true, that's the same bar we want to hold the machine to. I think one of the main points here is that Turing's setting a benchmark, something we can measure, something a little broad even, since it seems like there's no one test that will give us the answer we're looking for.
I think what's happening when you're really compelled by a good performer on stage who's improvising, what you're experiencing is them being very, very present. They are listening, they are affected by what's happening around them, and they are available in the moment. The things that are banging around in their brain, they're letting that come through their performance, but they're speaking the truth of who they are through the voice of a character that might have a different body and a different voice and a different way of seeing the world. And they're letting those things mingle. A good performer is accessing the deep vulnerability and courage of who they are. They're dovetailing that with a fictitious character who can speak these words for them in a safer package. And so I think the reason you get really attracted to certain performers and compelled by their shows and scenes is because they're actually sharing an honest bit of their humanity with you. And that human part of you recognizes that truth and that vulnerability and that courage. And so you respond to it and you kind of lean in and say, ooh, what is this person's name? I like this. I like them. They're good. They're funny.
In the idea of the Turing test, it's confined to this chat room for a lot of good reasons, right? Because then we can just talk about, is the conversation compelling? We don't have to bring in, the fact that you can see the person and all those sorts of details. So from like a scientific point of view, it's effective in how it isolates the people competing in this. But it also strikes me that it puts a lot of limits on a human performer. You don't have access to, how you emote. I mean, you can do all caps and stuff, but it really, your hands are tied, I presume, as a performer. Would you agree? What are the limits of just acting through typing alone?
Ooh, yeah. I think it diminishes everything entirely through text alone. I have that personal rule of like, whenever something kind of gets tricky in a relationship, like we can't do any of this over text. We can't do this by email or text. We have to have a conversation about it because you can't hear tone. The more we text, the better we get at it in terms of misspelling words intentionally to make it sound the way we're saying it, using all caps. And even in close relationships where you're communicating via text, you can kind of slip into an emotional shorthand with each other based on the vernacular that you've built up together. But for the most part, I think text is wildly limiting. It doesn't compare at all to being in the presence of someone.
If you were to maybe work with a programmer who wanted to make a machine like this, what advice do you think you'd give them to help them create a more human-like experience?
Well, it's so layered, right? Because you have to take in cultural influences and you have to take in the idea of emotion, because I'm a really emotional person. It's exhausting. I always admire people who seem to be less emotional than me because it looks like an easier way to live. And to get into the gender thing, in my culture, if you just talk about oversimplify male and female, the experience of being a female human or a male human growing up in a specific culture is so varied and colored. Like females in our culture are raised to be perfect and males are raised to be brave. And I know that's really kind of boiling it way down and oversimplifying it. But like, I would start there. There's all these, like, there's the expectations of your culture. There's the things that your culture builds into you. There's the way you emotionally respond to those things. And then how much, nurture, nature. Oh man, now I'm just talking myself in a circle. Is any of this making sense?
Yeah, absolutely. It is, definitely.
If you want to know what it was like to be Holly Laurent, who is a cisgendered female who grew up in the Midwest of the United States between the decade of 1970 and the turn of the century, I would say, if I was training a computer to do this, I would be like, okay, you have to read the whole Bible, and then you have to read the Northern Baptist version of the Bible, and then take a bunch of Sunday school classes and learn about what the Bible was telling kids about sin and shame and all of that. And then, you have to understand those emotions of feeling shame or feeling outcast, and the human experience of part of our wiring for survival is to be accepted by the group for safety in numbers. And so if you're raised to believe that you have to be accepted by the group to stay safe, then you have to understand all of those things that go into being accepted by the group. You have to have the right clothes, and you have to have a better body and a complexion and all of that. Start there, computer. Yeah. How would a computer understand the shame of having a blemish on your face and feeling like you can't go out of your house because you're so embarrassed of your appearance?
So I imagine it's a variable for everyone, but how long, generally speaking, does it take for someone to get, quote unquote, good at improv, to get past the hump and really be able to reliably own the stage?
There are special people who are pretty good right away, but for most of my students, and I say this, I do not say this facetiously. I usually tell people, like, just do it for 5 years. Like 5 years from now, you'll be so much more comfortable just in your own skin on stage. You'll be so much less concerned about the rules. I think people sign up and they take improv classes and they fill their brain up with a bunch of improv rules and they become kind of like an oversaturated sponge. And then it feels really hard and tricky, but if you stick with it, eventually what you do is you wring out all that like training and all those rules out of the oversaturated sponge, and that sponge becomes light and bouncy again. And then you start to just forget about all the shoulds and musts and you just start to play. It takes a long time.
I actually think that's a rather profound idea Holly's just given us. How long would it take to master this craft for a human being? For about 70% of the commercial machine learning work that I do, I train models in generally under an hour, sometimes really quick. It depends entirely on the data size. For the remaining 30%, and basically that's only deep learning, many models will run and take several hours, sometimes days, to converge. It takes the human machine several years to master language. Maybe the machine that eventually succeeds in the imitation game will need a similar training time. We'll be exploring that idea in a future episode. Our final segment today is an interview with Peter Clark from the Allen Institute for Artificial Intelligence about the work they're doing building question and answering systems, as well as a data set they've assembled to help other researchers do the same. That'll be right after the break. Hey listeners, let's show our support for Brilliant.org for their continued sponsorship of Data Skeptic. Brilliant.org is a unique and effective learning platform. This isn't just some silly brain trainer game that gives you some mindless puzzles. Brilliant has courses, and they're self-guided. They remember where you left off. And they teach with a comfortable pace of short instructional bits, followed by quizzes that test your understanding. Probability, logic, games of chance, complex algebra, linear algebra, the list goes on, and they really will appeal to Data Skeptic listeners. Check out their machine learning course if you're looking for a place to start. Thanks to all of you that checked out their mobile app after the last time I mentioned it here on the show. Whether you're on your mobile device or not, head over to brilliant.org/dataskeptic and see what they have to offer. All right, everybody, by now, you should be dying to read Turing's original paper. But Kyle, you say, I hate reading. I love audio. That's why I listen to podcasts. No sweat. I got you covered. Starting next Wednesday, we're going to be releasing a 10-part series where I narrate the entirety of Turing's original paper. That's going to be on the Data Skeptic bonus feed, not the main feed you're listening to now. If you're not on the bonus feed, search in your podcast player of choice or listen at dataskeptic.com. As of this release, we haven't pushed an update out yet, but come pretty soon you'll be able to click at the top on podcasts, and we'll have all episodes from both feeds, so you can listen there as well. Okay, on to our interview. This may seem rather obvious, but for the record, what is a question and answering algorithm? What's it trying to accomplish?
Well, the basic task is given a question, try and find an answer, and there are different flavors, though, of questions. The simplest kind of question would be, I give you a paragraph, and the answer is stated explicitly in that paragraph, and the task of the system is to then locate the answer within that, and that's been the basis of the Squad question answering challenge, which was one of the early and fairly well-known data sets. To get more complicated than that, we would have questions where a paragraph is not given, and instead the system has to find the answer somewhere from a large corpus, and systems that do that are just coming online now. But again, the assumption is that the answer is somewhere written down within the corpus. And then the third kind, which is the one that we are focusing on in this particular challenge, is where the answer is not explicitly written down anywhere. Rather, you have to combine a couple of bits of information together in order to come up with the answer. Those questions are very, very challenging, and our motivation here is to try to encourage the field of AI to give a bit more attention to these more challenging problems. The recent advances in AI have been focused on deep learning in the most recent years. One of the things that's fueled that is the large number of data sets that have become available. Although there have been big successes on these data sets, one observation is that many of the questions which these data sets ask about the data tend to be on the simple side. And so our goal with this particular question answering challenge has been to create a set of more challenging questions that are not so easy to answer using simple analysis of the surface features of the text.
So something like, what is 2 plus 2? The answer's not explicitly in the question, but I think it would be rather trivial to create a system that could answer natural language arithmetic questions. What makes these challenging questions harder than that?
You're right, arithmetic questions are more easy to answer because we have well-defined models about how to do arithmetic. There's a whole system of algebra that's available. These questions are in natural language, and this particular challenge concentrates on science questions. So the data set contains questions that have been extracted from exams which kids at elementary school or middle school would take. The challenge is that the knowledge that's required to answer them is somewhat difficult to pin down. It's not explicitly a set of equations that are needed. Rather, general common sense knowledge about the world is needed, combined with specific information in the question. And that's a very challenging area for artificial intelligence, and one which the field is still wrestling with.
Could you maybe give an example of one of the challenge questions?
Which property of a material can be determined just by looking at it? And it's a multiple choice question. So the answers are luster, mass, weight, and hardness. And in this case, the answer is luster. And the reason this is a challenging question is because there's no statements on the web that say things like you can determine luster just by looking at it, looking at a mineral. Rather, you would need to go to a definition of luster, which is about the shininess or the reflectiveness of a material. And then you'd need a bit of common sense knowledge that to detect reflectiveness, you would look at things. Being able to identify those are the two bits of knowledge you need and being able to combine them together is pretty challenging.
I have to confess, I was unfamiliar with the property luster before reading the paper.
Okay.
And I still don't know what units we measure it in. Yet, I was able to get that answer correctly, not just because the paper has the correct answer labeled, but with, I guess, process of elimination, maybe.
Right.
What is it about my brain that I have an advantage and I found that easy, whereas machines today find that so hard?
The two things. First of all, you have some background knowledge. So although you may not be able to give a dictionary definition of luster, you've probably got some memory of hearing the word before. You know, it's something to do with shine or reflectiveness. And so you're able to associate that with the particular question. And also the other answer options, mass, weight, and hardness, you can probably rule out because you don't determine mass by looking at something, nor do you determine weight by looking at something. So you also have some problem-solving knowledge that you are subconsciously bringing to bear when I give you that question.
How did you guys collect the questions?
It turned out to be quite difficult to get hold of these things. We've collected them over the last 4 years as part of Project Aristo. So Project Aristo is one of the main projects at AI2. It's the one that I manage. The mechanics of how we collected them was a mixture of finding publicly available exams online. It turns out they're quite difficult to find. Most examination boards don't like to make exams public. And then also establishing a number of agreements with a couple of suppliers that were able to provide us with these question sets. The thing which is very interesting about them is that they're natural question sets. So these are ones that haven't been modified or edited to prove a particular learning technique. Rather, they're real exam questions in the raw from outside. I mentioned this is an offshoot of Project Aristo. So Project Aristo has the goal of being able to answer questions like this. Part of our motivation in ARC is to get other groups involved and interested in this problem too. And it's a really, really fascinating challenge. When the system gets a question wrong, it's just fascinating to dig in and see what kind of mistakes the system makes and also uncover some of the common sense knowledge that we instinctively bring to bear when we answer these questions, which the machine doesn't have.
Yeah, there's an interesting design kind of challenge there that I see. When you find one of those questions that the system fails on, I imagine for some there's an instinct to I don't know, go and write a rule specific for just that case to kind of correct it. And that, to me, seems like the wrong thing to do, that you need to think, well, how do we more broadly adjust our algorithm to let it get a whole class of problems answered correctly? If you were trying to build a better system to do the answers, how do you maybe resist the temptation to overfit to questions and ensure that you're giving more generalized solution?
You're exactly right. We don't want to be hand-coding rules to fix the answers to specific questions. We have a testing set which we don't look at, and so even if we put specific rules to answer specific questions into the system, that's not going to help us on unseen test questions unless they just by chance happen to repeat. Rather, the methodology is looking at the ways particular questions fail, identifying what kind of knowledge is needed, and then looking at how to harvest that knowledge on a large scale from texts. The main way we are using structured knowledge in Aristo is not by hand-coding knowledge, but by simple forms of machine reading, where we go out to the web or selected text and try to mine large amounts of knowledge that will be useful for answering questions.
I can definitely relate to how difficult it must have been to collect all these questions, that there's not just some great repository, or there wasn't until now that you guys have provided it. So I hope that this data set can maybe eventually get the recognition that something like MNIST has, because I can see where it can be very valuable to a lot of people working on natural language. To wind up, I think we did cover this, but can you remind listeners what the challenge questions are? Because I think their presence makes the data set keenly interesting.
One thing we've done in this data set is to split the questions into two halves. So one is, we call it an easy set. The other set is called a challenge set. So the challenge set is defined as questions which both a simple information retrieval answering algorithm and a simple word correlation algorithm fail on. This is an operational definition of challenge. The reason it's significant is because with a data set where 50 or 60% of the questions can be answered by information retrieval methods, there's a strong temptation to then focus on tweaking and modifying the information retrieval system if you want to get your scores up. So we deliberately separated the data set into these two halves to try to avoid that. So in order to make progress on these harder questions, just tweaking an IR system is unlikely to be particularly successful. Rather, more other methods are going to be needed. So I think, yes, indeed, that does make it a very, very interesting set.
Absolutely. Question and answering algorithms have been around for a while, or at least attempts to do something interesting in this vein. Even, I would say earlier than a lot of people expect, there were attempts using, rather rudimentary information retrieval techniques. And you touch on some of those in the paper. Can you maybe describe the simplistic or naive approaches people have tried and the degree to which they're successful?
The simplest approach would be to take a question, for instance, the one I just described, which property of a mineral can be determined by looking at it, and converting it into a statement. So I'd take one of the answer options, in this case the correct one, luster, and I'd make a sentence. Luster is a property that can be determined by looking at a mineral. And then I would do an information retrieval search. I'd look on the web, say, for sentences which seem similar to that. And then I'd measure how similar the question and answer sentence that I had was to the best sentence I'd retrieved. And that would be a measure of how much I should believe that particular answer option based on how similar a sentence I can find on the web. That's a basic information retrieval approach. It actually works surprisingly well on full-way multiple choice questions for 4th and 8th grade science. So random guess will get you about 25%. Information retrieval approaches will get you around 50% on these questions. The thing which is surprising is that the system is able to answer these questions better than random without really having any idea about what it's talking about. It's simply finding something that looks similar. Our big goal at the Allen Institute is to get towards machines that really have some understanding of the world. And to do that, we're wanting to go beyond just these retrieval-based methods to systems that have some kind of model about the knowledge that they're manipulating in order to answer these questions.
I don't know if you'll appreciate the formalism I'm about to kind of lay on top of this, but in my mind, I feel like there's maybe 3 areas that one has to work on to build a system like this. First, there's some sort of a knowledge base, and we're fortunate in the modern era to have a lot of things like this. Wikipedia has some metadata to it, so there's lots of systems like that kind of have information about ideas and entities, and they link, and systems can benefit from that, or just a search of the web even. The web, in some sense, is a database. There's also, secondly, kind of the logic that one applies, common sense and reasoning and these sorts of things. And then perhaps third, there's algorithmic approaches. Do you agree, are those kind of the 3 major fronts of the battle?
So certainly the first 2 are paramount. So yes, getting the knowledge in some form that could be manipulated. And that could be anything from just working with the text itself to some kind of structured information. Second, yes, the problem of reasoning, which is how you then combine that knowledge together. The third category, which is also pretty significant when we think about it as AI2, is the business of understanding the question itself, so the question interpretation problem. And that itself is pretty formidable. Even if you have knowledge and you have ability to manipulate it, unless you can connect it to natural language problems that present themselves, you're not able to do anything.
What does that mean practically? Like, how does my code look different, or how does my software use memory differently in a way that's going to give me a little bit more understanding than just the raw correlations?
The basic change that we're trying to work with is, instead of trying to correlate an input signal with an output signal through a set of correlational layers, as one would do with a straightforward machine learning algorithm or a deep learning algorithm, we view the process as an iterative process where we take a question, we may do some retrieval and some updates of the representation we have of the question to expand what we know about it. And then we would do another inference step to retrieve more information. So there's a process in which the algorithms are gradually expanding what they can describe about a particular problem in order to find their way to an answer. The recent work in memory networks, for instance, in the deep learning field, makes a start on this, where they'll do multiple attempts to find which sentences are relevant to a particular question, and so do this kind of multi-hop reasoning in order to come up with answers. But it's still a very early stage in terms of that technology.
Yeah, speaking of the stage of the technology, when I was, an undergrad many, many years ago, I remember looking into image recognition and thinking how early stage it was. I mean, some very smart people were doing some very clever things, but today, we really have groundbreaking image recognition in a lot of ways in just a short period of time. Where are we on the question and answering arc? Are we in very early stages, or what do you think? How are things changing?
It's a little bit of a mixed bag. So in one sense, there's been huge advances in question answering. The new neural methods for answering simple questions have been amazingly successful. So the systems that are working on some of these well-known data sets like SQuAD and SNLI have significantly outperformed some of the early methods that were used for these kind of question answering tasks. On the other hand, question answering, which requires more than just the straightforward find an answer from surface features and text, still remains a big challenge, and progress there has been quite slow, I would say. We released a similar challenge to the ARC challenge a couple of years ago called the Kaggle challenge, and that was successful in that we had several hundred people competing on it. But the thing that was disappointing was that even at the end of the day, the systems that were performing best were those that were still doing the largely information retrieval and word correlation approaches. Nobody was able to get much traction on systems that could do reasoning and attack some of the more difficult questions in that set.
So how far away do you think we are from an algorithm, passing a college entrance exam?
I think to pass a college entrance exam is pretty challenging, but I think the progress is going quite fast. Certainly there's more interest. My take of the field at the moment is that there was this burst of enthusiasm in the NLP field with deep learning and large data sets. with a lot of successes on fairly simple question answering tasks. I believe the field now is thinking about what comes next. And there's been more interest in the last few months and the last year on looking at problems that do probe question answering in a bit more depth. And the paper that we're talking about here, the ARC challenge, is one example of a question set that's trying to push on that, but there have been a couple of others that have been released as well, looking at multi-hop reasoning for question answering. And I think that growing interest will mean progress is going to be made in the next couple of years. Now, to get up to the level of a college entrance exam is quite a substantial leap further forward, because it's not just a matter of questions there involved, not just a matter of chaining a couple of facts together, but really having some deep common sense about the world and being able to apply it systematically. So college entrance exams, for instance, often involve not just factoid question answering, but maybe writing an essay, reading a paragraph, and answering fairly sophisticated questions about it. Those things are going to be much more challenging to attack.
Yeah, in that respect, I guess question and answering is sort of a subset of natural language, because there are other natural language tasks which aren't question and answers. But it seems like question and answering is a very difficult challenge. How different do you think it is between question answering algorithms and the Turing test? For example, if you were eventually to invent the best question and answering algorithm that humankind has ever seen, how many steps away are we from a machine passing the Turing test?
Well, so that's a great question as well. I mean, the Turing test has come under a lot of debate in recent years because there have been systems built that, at least within some narrow constraints, have been able to fool human judges. But of course, Alan Turing wasn't after systems that could fool people. He was after systems that really could genuinely claim to be intelligent. Question answering itself is a little bit of a poorly defined subject. I mean, you could define everything as question answering, but certainly the kind of question answering that we have in this challenge, I would say, would be part of a test of intelligence for a machine. But it's not the only test. And I think these days, common belief is that a good Turing test would be more like a Turing Olympics, where there would be a number of different skills that we associate with intelligence that would be tested. So one would be question answering, but another might be dialogue and discussion. Another might be visual processing, and it could even extend up to spatial reasoning and being able to navigate around an environment. So there's lots of different aspects of intelligence that come to play. Question answering, though, does cover a pretty core part of that, and a system that really could answer complex questions, including those which require more than just looking up a fact in a large corpus, would be a big step towards achieving machine intelligence, which was Alan Turing's dream.
So there are a number of systems that today are trying to do some amount of question and answering, all these voice assistants that are coming into the home, and even, search engines to a certain degree. And I realize you don't know the inner workings of these private corporations, but I'm curious how you, as someone knowledgeable about question and answering, if you are to ask questions of those types of machines, can you determine sort of the level of sophistication they have, or even recognize when they've done an upgrade?
Well, I think anybody who's tried asking questions to some of these voice assistants realizes pretty soon that for the most part, they don't understand what they're talking about. So yeah, it's possible to ask questions relatively easily that will clearly indicate that they don't know what they're talking about. One of the interesting things, though, about the voice assistants is they do have little niches where they do seem to have some expertise, and this is where somebody has gone in and built a model of a particular topic into the system. So a good example would be restaurants and booking a meal in a restaurant. So some of these voice assistants are able to handle that a bit better than other queries, because there is a model inside the software that knows a bit about restaurants, that restaurants take reservations, and that reservations are at different times, and the bookings can be full and not full, and to make a reservation you have to do this certain thing, and knowledge about calendars. So that's kind of a little hint of the machine at least understanding something about a very, very narrow topic. A system that had that kind of knowledge about many, many areas of the world, and including fuzzier areas than booking a table at a restaurant, would be very impressive.
So I know you did this work in collaboration with a number of people at the Allen Institute for Artificial Intelligence. Can you tell me a bit about the place?
So the Allen Institute was created by Paul Allen 4 years ago. It's a not-for-profit research foundation, and its mission is to make big advances in AI, in particular to push on some of the technologies that would help us move faster towards really intelligent systems. So technologies that endow the machine with some degrees of common sense, that would allow it to do interesting forms of reasoning and understand the world. The Institute has about 60 employees. We're based in Seattle, and we're very mission-focused towards those ends.
In terms of getting the data set, what would people have to do to take steps if they wanted to try their hand at building a question and answer system?
Well, I would strongly encourage people to try this. It's a very interesting and very challenging set. So to do that, the easiest way is go to our website, alanai.org, and then under research, there's a section called data, the AI2 reasoning challenges at the top of that page. And from there, you can download the data. There is a corpus which goes with it. We don't require people to use the corpus, but for people who are wanting to use corpus-based methods, it's a good starting point. The corpus is a large volume of science text relevant to the questions in the challenge. Thirdly, we've also included several baseline systems, including two of the state-of-the-art neural systems on question answering. One is the re-implementation of a system called BiDAF, and another one is another system called the decomposable attention model. So those are available for people to try, and they're in a pretty easy-to-use NLP framework, which is also from the Allen Institute, called Allen NLP. It's a deep learning toolkit built on top of PyTorch for doing NLP reasoning. These are all tools that would, I think, help people to get started very easily.
Turing predicted that by the year 2000, interrogators would be only 70% accurate at picking which of the two conversation partners was a machine. He was wrong. We're not at that benchmark even today, but Turing was no slouch. This wasn't like the baseless predictions that so-called futurists make today. Turing knew that the machine he dreamed of was capable of winning the imitation game. He just overestimated how quickly Homo sapiens would figure out how to do it. Was he too optimistic about the hardware or the software? Probably both, but let's start with the hardware. What's missing today? Although a single transistor and a single neuron are hardly comparable, they're both countable and should be asymptotically similar. The brain has more neurons than the best computer has transistors by a long shot. Perhaps by the time the engineering efforts are sufficiently advanced, AI will inexplicably emerge before our very eyes. I personally doubt it, which brings us to the software. I think Turing underestimated the effort to make the software, and especially the importance of machine learning. In Turing's time, the advantage of a massively parallel system might not have been clear. The power of methods like autoencoders had yet to be described. Knowledge representation wasn't much of a field. And although the earliest ideas of all 5 tribes of machine learning were, arguably, starting to appear in the literature, no one yet had an inkling of how we tie them together into one master algorithm. One of the challenges for artificial general intelligence is the lack of a clear objective function. Although many unsupervised techniques exist in machine learning, it's not clear how we're going to lay the numeric breadcrumbs to lead the optimization to general intelligence. Perhaps generative adversarial networks are a step in the right direction. After all, what is the imitation game but a human interrogator as the discriminator and a machine as the generator? But let's not forget that at the core of the imitation game is the act of deception. To deceive someone requires that you're able to reason about their existing knowledge and how they'll integrate new information into their beliefs. That's a property that machines will seemingly need to develop on the road to AGI. All things considered, my own point of view is that the so-called Turing Test is more relevant today and no less applicable than when it was first described last century. The finer points are often overlooked or misunderstood, but as we continue to build better machines, we're eventually going to build one that thinks. I just can't say exactly when. The Turing Test isn't a measure of intelligence, not exactly. It's an isomorphic question to the question, can a machine think? I'm sure that the answer is yes, but how we get there isn't totally clear for me. At least not yet. I've got a couple of more decades of episodes in me. We may meander a bit, but I'll try to get you to a clear answer eventually. Now, not everyone's as satisfied with the Turing test as I am. Listeners, what do you think? Head over to dataskeptic.com and click Contact Us and leave us a voice message right in your browser. I want to hear your thoughts on this. Is the Turing test relevant today? Next week on the show, we'll hear from one AI researcher who seems to think that the Turing test isn't enough. Okay, thanks to everyone who participated in my 2027 skit that opened the show.
Christine DeLeon
Was our first reporter. I'm glad to hear you'll still be with Data Skeptic in 9 years.
Catherine Grant Sutty.
Played our CEO, Jane Smith.
Leisha Hackney
Was our second reporter. And thanks to the 3 other podcasts who apparently were also able to get press credentials for this event in the future.
I'm Samuel Hansen, host of the Relatively Prime podcast. You can find us at relprime.com.
Jeff from Software Engineering Daily.
Carl Mamer from the Conspiracy Skeptic podcast.
Thanks to Peter Clark from the Allen Institute for Artificial Intelligence and Holly Laurent.
On Instagram, I'm Holly Laurent, and on Twitter, I'm Laurent Holly.
And last but not least, thanks to all the generous Data Skeptic members. We couldn't do the show without your support.
Okay, upcoming events. Seattle, Washington, Monday, May 7th. I'm going to be in Seattle for Microsoft Build, and I'm hoping to organize an informal listener meetup. Any locals with a location suggestion, please send that my way. Could really use your help. Chicago, Saturday, May 19th. I'll be giving a talk at the Data Science Conference being held at the University of Chicago's Gleacher Center. It's not on the campus. That's over by the Wrigley Building. Check out the show notes for ticket information. My talk is about machine learning, AI, and the blockchain. Come out and hear a skeptical perspective on the intersection of those topics. I'm also really hoping to organize a meetup for earlier in that week. I'm thinking like Monday or Tuesday. If anybody is a local company with space, please reach out to me. I'm looking for a venue. I have a special guest confirmed. It should be a marvelous event. Berkeley, California, Sunday, June 10th. I'm giving a talk at SkepticalCon. Tickets just went on sale and it's guaranteed to sell out. SkepticalCon.com. That'll be in the show notes.